Hi, welcome to AB Video 7.2B Part 1. More on volumes by revolution by disks and washers now. All right, so 11 to 14, find the volumes of the solids generated by revolving the regions bounded by the graphs of the equations about the given lines. So in this case, you have the region bounded by y equals 2x squared, y equals 0, which is the x-axis, and the vertical line x equals 2. And you hold on. Okay, so this is the x-axis, and then we're going to revolve it about the y-axis. So here's our picture. Here's our graph of y equals 2x squared, vertex 0, 0. Here's our x-axis, of course, and here's our x equals 2. So we're talking about this region that's bounded by the parabola, the x-axis, and the line x equals 2. Now we're revolving it about the y-axis. So remember, that means we have to draw the rectangular strip perpendicular to the y-axis. Now again, remember how I do this. This is going to be a washer, by the way, and the reason it's going to be a washer is the y-axis is not one of the borders, the three borders of this shaded region. So there's this gap in here. So what I do to draw it is I go, okay, here's my y-axis, here's my point xy. I have that little distance here, so I'll reproduce it on the other side because I'm going to be rotating. And then I have the distance between the point xy and the line x equals 2, which is this distance from here to here. I reproduce that distance over there. So you end up with 5 little tick marks. You join the outside ones with an ellipse, and then you join the 2 inside ones with another ellipse. And this is your center. And then you give it some thickness. So our height is going to be dy, which tells us everything will have to be in terms of y. Our radius goes from the center, there's a big radius and a little radius, right? So I don't know why I didn't write little r anywhere, but the big radius goes from the center to the outer edge. So my big radius is actually the distance between the y-axis and x equals 2, which is going to be 2. My little radius, which is right here, is actually the x coordinate of that point. So we have pi big R squared minus little r squared h. My h is dy. Since my h is dy, this has to be from y equals to y equals 2, which is bottom border y equals 0, top border y equals 8. My big radius, if you remember, we figured out was 2, and my small radius was x. So 2 squared minus x squared. Remember, this is not 2 minus x all squared. And I'm just setting these up. After that, you would either evaluate it by hand or with a calculator. Okay, we're going to take the same region, but this time we're going to revolve it about the x-axis. Well, now we're going to get a disk because the x-axis is one of the borders. We'll get pi r squared. The x-axis is horizontal, so the little rectangular strips have to be vertical. And when I rotate that over, I'll have the distance between the x-axis and that point and reproduce that same length down here. My height is horizontal, so it's dx. My height is right here, this little tiny horizontal length, which means everything's in terms of x. My left border is x equals 0, as you can see. My right border is x equals 2. And now my radius, of course, my radius being this right here, is the height of the point xy, making it the y coordinate. So r squared becomes y squared. But I have to have everything in terms of x, so I go back to the fact that y is equal to 2x squared. I replace y by 2x squared. You can take it from there. Another example here. Same region, but we're going to revolve it about the line y equals 8, which is this green line right here. Horizontal axis of rotation, rectangular strips have to be vertical. Make sure your rectangular strips go from, in this case, the bottom of the shaded region to the top of the shaded region, not beyond it, not underneath it. Okay, so obviously we have a gap. We do not have a border of y equals 8, so we're rotating on something that's not one of the borders, so we're going to get a washer. So we come over here, it's pi integral big R squared minus little r squared h. So I have from here to here, that's these two little bars right there. Then I have this distance between the top of my rectangular strip and my axis of rotation, which is from here to here. So whatever that length is, we produce it here, put a little bar. Whatever the length is between these two, we produce it up here. join the outer, join the inner, and there's your washer. So you can see that our washer has a height of, that's horizontal, so that's dx. So we have left border to right border, which is x equals 0 to x equals 2. My big radius would be from here to here, which would be this right here. Well, this is the line y equals 8, and this is y equals 0. So obviously my big radius is 8. My little radius, be careful, is not y. My little radius is this length between here and here. From here to here is y. From here to here is 8. So the remaining little part that is my little radius is 8 minus y. Okay. Sorry about that. I have so many interruptions. Okay, so we're looking for this is our little radius from here to here, which is here to here. So we know from here to here is 8, because that's the line y equals 8. And from here to here is y. So this little thing is 8 minus y. So it's 8 squared minus 8 minus y squared. I don't know. I'm not even. You can't leave the y. That one thing you cannot do because this is in terms of x. So of course, remember, it was the equation y equals 2x squared. Again, same region, revolved about the line x equals 2. X equals 2 is one of the borders, as you can see, so it will be a disk, pi r squared h. Since the axis of rotation, AR, is vertical, our little rectangular strip has to be perpendicular to it, so it has to be horizontal. So I have from here to here, and I'm going to rotate it about there, so I end up with this disk right here. My height of my disk, or my cylinder this time, is vertical, so it's dy, so this has to be from y equals to y equals, which is bottom border y equals 0 to top border y equals 8. And now I have radius squared, and this is why you want a good picture that's not microscopically tiny. The radius goes from here to here, which is from here to here. You know that from here to here is 2, because that's the line x equals 2. You know that from here to here is the length x, because that's the point xy. So this green will have the length 2 minus x, and there's your 2 minus x. And then etc. You will have to replace the x in terms of y, and then we go back to the fact that they had told us that y was 2x squared, and then you just take that and isolate your x. You can tell it's in quadrant 1, so the x will be positive, but x gets replaced by the square root of y over 2. And then here you could let u equal y over 2, etc., or you could just expand this, it wouldn't matter. Oh, obviously somebody asked me to actually expand it and blah, 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 but I got bored. Look, see?